Okay.
It's recording.
It says it's recording. I hope it's recording to the cloud. Okay, I hope this is working. Okay. Looks like it's recording. Okay.
Good morning, Professor. Good morning, all.
Good morning.
Good morning.
How are you?
I'm good, thank you. How you doing?
Good.
You sound better than yesterday.
I know I didn't sound well the other day. maybe the computer is better.
Okay.
Hi, good morning, everybody. Okay, I'm giving you a few minutes to do these two problems. Okay, I think let's get started on question number 1. Let's remember that when we want to solve a rational equation, the first thing we want to do is figure out what is the common denominator of the whole fraction, which means that any whole number you should put over 1, and then go to all the denominators and factor them as much as you can. So this has a denominator of 1. This has a denominator of x minus 1. You can't factor either of those, but this x squared minus x can be factored to x times x minus 1. And if I look at, and again, I like to do it using the circling, all the different denominators that I see a 1, I see an x minus 1, I see an x, all these are different, and then I see an x minus 1, which I already have circled. So if I put all those things next to each other, well, the one I don't have to put, but my common denominator comes out to be x and x minus 1. Okay, so those are the different factors that I'm seeing, so that makes the common denominator. Now I have to rename the numerators. I have to change the numerators. Well, I look at my first fraction, and I don't have an x, and I don't have an x minus 1 on either of those. So therefore, when I divide the 1 into this whole thing, I get the x and the x minus 1, which makes sense. this fraction was equal to 1. So the numerator and the denominator have to be identical. Then I go to my second fraction. I have the x minus 1 there. What I don't have is the x. The x is not here, so I've multiplied this by x. So I have to take my original numerator and multiply it by the x. And finally, on the last fraction, I have both the x and the x minus 1. I have not changed the denominator at all, so therefore I don't have to change that numerator either. So it turns out that my equation, I'm going to go over here to finish this up. Remember, once the denominator is all the same, I can write the numerator as the equation. So I have x times x minus 1 plus x times x equals 1. I've made it into a much simpler equation, but I can't get rid of the denominators until all the denominators are identical. And now I have to remove the parentheses. I used to use distributive property. So this will be x times x is x squared. X times negative 1 is negative x, plus x times x, which is also x squared, equals 1. And when I combine the like terms, the x squared and the x squared give me 2x squared minus the x equal 1. And it's obviously a quadratic equation because I have this x squared. So I'm going to bring the 1 over to the other side to set it up like a regular quadratic equation. So what I end up, after all this work, is a quadratic equation 2x squared minus x minus 1 equals 0. And I have two choices at this point. It's a quadratic equation, I can factor it, or I can use a quadratic formula. I think today I want to use a quadratic formula simply because we have to keep reminding ourselves of the quadratic formula, though this definitely would have been factorable. Okay, if I'm using the quadratic formula, I better write it down. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, my a is the 2. The b is the number that's in front of the x, which is a negative, so that's really a negative 1. And the c is also negative 1. So when I substitute this in, I get negative, okay, here's my negative b, my b, negative 1, plus or minus b squared, so that's negative 1 squared, minus 4, my a is 2, and my c is negative 1. Better give myself a little bit more space. And that's all over 2 times 2. Okay, and now I've got to simplify. So the negative and the negative become a positive 1. And here's where I have to be really careful. Negative 1 squared is positive 1. And negative 4 times 2 is negative 8. Negative 8 times negative 1 is plus 8. So the whole thing comes out to be 9. That's in the radical. And that's all over 4. Which gives me 1 plus or minus square root of 9 is 3 over 4. So here are my two answers. 1 plus 3 over 4, which gives me 4 over 4, or 1. And 1 minus 3 over 4, which is negative 2 over 4, or negative a half. Now I got two answers to this question. My two answers that I came up with were, going too high. The two answers I came up to were x equals 1 and x equals negative a half. But remember, I have to go back and check to make sure these are not what we call extraneous roots, that neither of these roots are going to make a denominator equal to 0. And if you notice, when I have x equal to 1, the first number is fine, but the second one becomes 1 over 1 minus 1, which is 1 over 0. So this is an extraneous root. I have to throw it out. The negative a half doesn't make anything equal to 0. It's obvious. This is not 0. The only thing that would make it 0 was actually the 1. So the one answer that's correct is negative a half. I did see a couple of people did come up with that answer. This is a particularly difficult example. It's difficult because you have to make all these arrangements to get rid of the common denominator, and then you have to solve the equation. Let me make one comment about this. If you would get this on a final exam, an example like this, what you could see right away is if they gave you an answer like 0, you'd know that couldn't work, because this would make this would be 0 times, the 0 would make this denominator 0, and the 1 can't work. So you'd be able to throw out a couple of the answers. Any answer that would have a 1 in it would right away have to be discarded. And it's very likely what they would give you as answers is negative a half separately, 1 separately, 1 and negative a half together, which a lot of people might pick, and then some other answer. But any answer that has a 1 in it, right from the start, you should see that 1 cannot be an answer because it makes the denominator equal to 0. If you don't have time to do this whole process, you could at least eliminate some of the wrong answers by picking out the answers that would be extraneous roots. Does anybody have a question about this? Okay, so I see Devani even put an answer. Devani, you want to lead us through this one? Because I see you put an answer here. Can you do that? Devani, are you there? Okay, I guess she's not there right this minute, so let me do it. Let's see if we can remember how to do this dividing of a polynomial, in this case happens to be a trinomial, by a monomial. What I told you to do in that case is to take each of the terms separately and put it over the denominators. Separate it, since there's 3 terms, into 3 different fractions. 6y over to the 4th over 9y squared minus 3y to the 3rd over 9y squared plus 9y squared over 9y squared. So rewrite the problem, putting each of the terms from the top over the denominator, and then reduce each of these fractions. Remember, we look at the These are all monomials, so we just look at each part separately. I have a 6 here and a 9 here as coefficients. Obviously, they're both divisible by 3. So on top, I'll get a 2. On the bottom, I'll get a 3. And remember, when it comes to the variables, you cross out the variable that has the lower exponent, which in this case is the y squared. And you subtract that exponent from the higher one. So 4 minus 2 is 2. And we're left with the y squared in the top. So my first fraction becomes in simplified form 2y squared over 3. Then we go to the second one. There's a 3 on top and a 9 on the bottom. They both divisible by 3, so this cancels out, and I'm left with a 3 in the denominator. Again, the lower exponent of the two variables is the 2. So again, the y squared gets canceled out. 3 minus 2 is 1, so I'm left with y to the 1, which is just a plain y on top. So my second fraction became minus y over 3. And finally, the last fraction, the 9's both cancel out, and the y squareds both cancel out. Don't forget, when everything totally cancels out, you're left with 1 over 1, which is just plain 1. You'll know that you don't leave this last one out. That happens to be a common error. Everything cancels out, you just drop it. You don't, this is division. You're left with a 1, and you originally started with 3 terms, so your answer should have 3 terms.
Professor, one question. How did you get the 2y at the beginning? Because I see there's 2y over the 6.
Here I
It's
had a
three-
6 on top and a 9 on the bottom.
Mhm.
So both of them are divisible by 3. So 6 divided by 3 gives me 2, and 9 divided by 3 gives me 3. That's how I reduce the 6 over 9 to 2 over 3.
All right, thank you.
Any other questions? Okay, so this takes us to the last topic in chapter 5, which is what happens when we're dividing, and what we're dividing is a polynomial on the top, but also a polynomial. It's not just a single term in the denominator, but it happens to be a binomial. How do we divide by a binomial? Okay, so that's what I'm going to do next. Does anybody mind if I erase what's on the board? Okay. Then I'm going to erase the whole board because I'm going to be using, these problems are long as well. Okay, so let's say I had this question. If you notice, I'm doing a regular division of numbers, because what we're going to see is the process of dividing a polynomial by a polynomial really mimics all the steps that we learned in doing long division. And since most people I believe, are like me, that if they have a long division problem like this, the first thing they do is take out their calculator and just throw it into the calculator. Let's remind ourselves of the steps involved in doing a division like this, along using all the steps of the long division. And if you recall, the first thing is if you're dividing by 25, now 25 is not so hard, but usually if it's a longer number, you sort of estimate 25 is close to 30. Let's use just 3 instead of 2. Let's divide the 3 into the 4. Now the 3 into the 4 goes once, so 25 actually into 46 goes once, and you put a 1 on top. Notice we put the 1 over the 6 because this is 2 digits, I have to put it over the second digit. When you're doing a long division problem with numbers, you have to be very careful as to placement. We're going to not have to be so careful when it comes to the polynomials. But the 25 into the 46, we divided, we got 1. We put our answer on top, and what's the next thing we do? We multiply the number that we put on top by the divisor. 1 times 25 is 25, and I put the 25 under the 46. I know to put it under the 46 because that's where the 1 is. And after I do this, I'm going to write down the steps in a minute. So I divided the 25 into the 46, put my answer on top. I multiplied the answer times the divisor, and the next thing I do is subtract. So I have to subtract. 6 minus 5 is 1. 4 minus 2 is 2. And my next step is to bring down the next number, which in this case is 2. And I start all over again, and I do 25 into 212. Well, that looks to me, I think 25 goes into 200 8 times, so it looks like about 8. Let's try an 8. Remember that this number I'm just estimating. It's someplace between 7, 8, 9. I'm just guessing a little bit. I'll know if I'll guess correctly because when I do subtract, my answer has to be lower than the divisor. Okay, so I do, now again, I put a number on top, I multiply by that number. Just by the 8, I don't multiply by the 1, I just multiply by the 8. 8 times 5 is 40. And 8 times 2 is 16, plus that 4 that I carried is 2, right? 8 times 25 is 200. I multiply, and the next thing I do is, again, I subtract. So 2 minus 0 is 2, 1 minus 0 is 1. I'm left with a remainder of 12, and I bring down the next number, which is 128. And again, I start the process again. I divide the 25 into 128. Now, I think you probably might realize that it's 5 because 5 times 25 is 125. I put the 5 on top, and I take that number that I just put on top and multiply. 5 times 25 is 125. And again, after I multiply, I subtract. That leaves me a remainder of 3, which I know is okay because it's less than the 25. Now, what your calculator, if you would have put this in your calculator, would have done, it would have continued going into decimals. But what I'm going to talk about here is division with remainder. If we don't want to go into decimals, my last number that I got was 3. I can't divide 25 into 3 anymore. There's no more numbers left because we're not putting in a decimal. So this is what we call our remainder. Our remainder is 3. So the answer could be written this way. 185. It's called the quotient, by the way. The answer to a division is the quotient. 185 remainder 3. Or what is often done is we take the answer 185 and put the remainder plus the remainder we put over the divisor. In other words, my answer would be 185 plus the 3 over 125, 3 over 25, usually written right next to each other. 185, 3, and 3/25. Notice when you write numbers right next to each other, a fraction next to a number, it means that you have this and this, like 2 with a half next to it means 2.5. This means 185 and 3/25. So that's what we call division with remainder. Okay, let me just remind you what the steps were. Step 1, we divided. Step 2, we multiplied. Step 3, we subtracted. Step 4, we brought down the next term. Let's call it bring down. And step 5 is repeat until you can't go any further. So it's divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay, this was a reminder of long division with numbers. How does this work with polynomials? So let's say I gave you an example like this. I want to divide 6x squared plus 7x minus 18 by, I'm dividing, usually sometimes I use my fraction to indicate division, but the answer is it says divide. It's not reduce to fraction. It isn't simplified. The instructions said divide. And notice what I have on my numerator is a trinomial, 3 terms. And in my denominator, I have a binomial. I have 2 terms. So basically, I have a polynomial on top divided by a polynomial on the bottom. Whenever I have that situation where I'm dividing a polynomial by a polynomial, I have to set it up like a long division. I can't separate it like we did the polynomial over the monomial. This has to be done by long division by these steps that we just talked about. Now, there's a couple of things that you have to be very careful about. Number 1, you have to have your polynomials in descending order. The highest power, then the next highest power, then until you get to the number. Both the numerator and the denominator, both the dividend, what you're dividing into, and the divisor. You rewrite that like the long division. You put the 3x minus 4 on the outside, and on the inside, you put the 6x squared plus 7x minus 18. So you set it up like a regular long division. And what we're going to do is we're going to take this 3x minus 4 and divide it into here. Now, it's very hard to divide by 3x minus 4. So instead of that, I'll make my life a little easier. I'll just do the division by the first term by the 3x. So step number 1, divide by that first term, 3x into 6x squared. First term into first term. So when I divide the 3 into the 6, I get 2. And when I divide the x into the x squared, you get x. Remember, when you're dividing the variables, you're subtracting their exponents, and the 3x has an exponent of 1. So ignore that -4 for this first step. Just take your first term, divide it into your first term. And it doesn't matter where you put that answer. You could put it over here, you could put it over here. Where the answer ends up doesn't matter. It's not so much as important as where we put the numbers in when we were dealing with numbers. When it comes to the variables, it doesn't matter. Okay, so that was our first step. Now the second step in long division was to multiply, and that's exactly what we're going to do now. We're going to take the answer that we just put on top, which is the 2x, and multiply it by the divisor. But when we do the multiplication, just like when we multiplied over here, we multiply by the whole divisor. We're going to have to do that as well. We're going to take the 2x and multiply it by the 3x, which will give me 6x squared. But I also have to multiply the 2x by the -4. That will give me -8x. So step 1, divide. Step 2, multiply. We're up to step 3. Step 3 is subtraction. Now I want to subtract this polynomial minus this polynomial. Now, if you remember with subtraction, usually what we do when we're subtracting, we want to subtract this whole thing. We don't want to just subtract the 6x squared, but everything. So we're going to do it by changing the signs. The rules for subtraction really means multiply by -1. This will make this a -6x squared, and it'll make this -8x a plus 8x. Because when you're subtracting, you are changing the operation from subtraction to addition by changing the signs. It's the easiest way to do it. That'll give me, so I don't have to keep reminding. Once I change the signs, I can just go ahead. 6x squared minus 6x squared cancels out. Now, what I'm doing is 7x plus 8x, because really what I was doing was 7x minus -8x. So I've already taken care of the fact by changing the sign. 7x minus plus 8x gives me positive 15x. So when you're doing the subtraction, change both of your signs so you can just add. It's the easier way to go. Okay, so now we've done the dividing, the multiplying, and the subtraction. We're up to step number 4. Bring down the next term, which is -18. And now we start the process again. We take our 3x, remember when we're doing the division, we're only using the first term, into the 15x, 3x into 15x. The 3 into the 15 gives me 5. The x's cancel out. Don't forget, x into x does not give me x. It cancels out. You put the 5 on top, and then you multiply by what you just put on top, which is the 5. 5 times 3x is 15x. 5 times -4 is -20. And now again, we subtract. And remember how I want to do the subtraction by changing the sign. So this is going to become a negative, and this is going to become a positive. And now I have the 15x minus the 15x, which cancels out. And the -18 plus 20 gives me positive 2. And now there's no place else to go. So this is my remainder. And I can either write my answer as 2x plus 5 remainder 2, or more likely 2x plus 5 plus the 2 over the 3x minus 4. Take your remainder and put it over the divisor, and that's probably the more common way of leaving the answer. Again, step, divide, multiply, subtract, bring down. Divide, multiply, subtract, bring down. Okay.
I have a question, Professor.
Sure.
Factoring wouldn't work in this because I don't like this. When we have to do the long division in terms of the equation, so factoring wouldn't work in this one.
No, you know what? The only time factoring would work is if there was no remainder. A factor means that it divides evenly. Dividing evenly means that's nothing left over. So I'm going to do, I know it's a long process, but I'm going to do a couple more. I think once you've done a few of them, you'll get used to it.
Okay.
In terms of the final, there'll be one on the final, but there for sure will be one. So it's not as if you can totally avoid it, but it's not like there are going to be 10 of these kind.
Professor,
Yes.
this dividing long division, we're dividing what?
It's called dividing a polynomial by a polynomial. Or you could use it long division of polynomials.
All right, thank you.
Whichever way you want to write that. Should I do another one? Does everybody have this written down? Anybody needs some more time to?
Yes, I need more time.
Okay, I'm giving you, well, you know what? I'll take attendance while you're copying that down. Okay, Azia, that was you. Nashia Allen. Is Nashia here? Nashia? Annabelkis. Annabelkis? Emma. Well, Emma told me she's not going to be here. Messiah. Is Messiah here? We're not doing too well today. Corey?
Here.
Oh, good. Thank you. I'm glad you're here. April? April Chung?
Present, Miss.
Good. Khadija? Khadija here? Umar. Umar Diallo?
Yeah.
Umar, did you take the midterm?
Yeah, I did.
Oh, okay. Oh, yeah, you did. I'm sorry. You did very nicely on it yet.
Thank you.
Good mark.
Thank you.
Yakima? Yakima Ellison? Cheryl, I know you're here. Stacy, I know you're here. Denisha, I know you're here. Devana?
Present, Professor. I'm
Good.
here.
Good, I'm glad you're here. Natalie, I know you're here. Erica, I know you're here. Jonathan, I know you're here. Luke Minot.
Here.
Luke, you didn't take the midterm yet, right?
I started, but I got kicked out.
Okay,
Like,
just email me when you're ready to take it so I can set it up for you.
All right.
Okay? But don't let it go too long. Layla Naji.
Yes, Professor, I'm here.
Good, thank you. Ashley,
I'm here.
Ashley, were you here on Tuesday?
No, I wasn't here on Tuesday.
Okay. Sometimes I mark people absent and then I think it's a mistake. Okay, thanks. Kachira, my good students, I need you here. Kachira. Guess you're not here today. Jennifer, I know you're here.
Yes.
Rachel, I saw you're here. Gloria. I don't know. Does anybody know Gloria Villalba? Anybody? Because I'm wondering if she just dropped the class. Okay, not here. Okay. Zia, can I erase it now?
Yes.
Okay.
Yes.
Okay, great. All right, I'm gonna go through a problem totally again. And then I'm gonna give you one to try. Okay, so here's a question. I want to divide 6x to the third minus 4x plus 7 by the polynomial 2x minus 2. This actually happens to be problem number 14 on the chapter 5 set of problems. Okay, it is a trinomial divided by a binomial. I know I'm going to have to set it up like the long division that we did before. And I have to make sure that my numerator and my denominator, my dividend, what I'm dividing into, and my divisor are in descending order. And they are. They have the highest power first, the next highest power, the next highest power. So I'm going to put the 2x minus 2 on the outside. That's what I'm dividing by. And on the inside, I'm going to put the 6x cubed minus 4x plus 7. But I noticed something very, I won't say strange, but different here. I see that my first term is 6x to the third. The next term I should have then should be an x squared term, because if I'm doing it by descending order, it goes x3, x2, x, and then the number. Descending order means start at the highest power and then go down. There is no x squared term. I'm missing an x squared term. Now, in most cases, we just leave it like that, so it's missing. But when it comes to this long division, it's important that you have each space filled. It's like if you have the number 105, you have a 1 and you have a 5. But we have to put a 0 in the middle because we need it for the spacing. If I left out that 0 from 105, it wouldn't say 105, it would just say 15. The same thing is with this long division. I have to have every space accounted for. So I'm going to put a 0x squared, or I could just put a 0 in the x squared position. I need to keep the position open. Then after the x squared, I'm going to have a negative 4x and a plus 7. So not only do I have to have them arranged in descending order, I have to make sure that all terms are accounted for. If I've done my setup correctly, which I have now, then the rest will flow. I take my first term, the 2x, and divide it into the first term. Step number 1, divide. So 2 divides into 6 and gives me 3. And x into x cubed, remember I'm subtracting the x components, 3 minus 1 gives me x squared. So the first answer I got on top is 3x squared. I take that number that I just put on top and up to step 2, I multiply. So I multiply the 3x squared times the 2x. That gives me 6x to the third. And I multiply the 3x squared minus times the negative 2, which gives me negative 6x squared. That's why it was so important to have this space. I had to have the space to put, where should I put the x squared? I have to put the like terms under each other. If I didn't have that space, this would have come under the x's and the whole thing would get mixed up. So that's why I needed this 0. So that was the multiplication. I now do the subtraction. Subtraction, I said the easiest way to do it is to change your signs. This is a positive 6x cubed, so it's going to become a negative. This is a negative 6x squared, so it's going to become a positive. Change both signs, and then do 6x cubed minus 6x cubed. That cancels out. And 0x squared plus 6x squared gives me a positive 6x squared. So I change the sign and then just add down. And after I've done the subtraction, I bring down the next term, which is negative 4x. And I start all over again. I take my 2x and I divide it into the 6x squared. So again, 2 divides into 6 gives me 3. And the x into the x squared, remember I'm subtracting those exponents. 2 minus 1 is 1, so it's x to the 1, which is just a plain x. So I get on top 3x. What I just got on top, the 3x, I now multiply by. 3x times 2x is 6x squared. 3x times negative 2 is negative 6x. So I multiply, now I'm subtracting. So I'm changing the sign. This is becoming a negative. This is becoming a positive. Remember, whatever sign they are, I just switch it to the other. If there's no sign, obviously it means it was originally a plus, so it became a minus. And I get the 6x squared minus the 6x squared canceling out. And now I have negative 4x plus 6x, which gives me a positive 2x. And after the subtraction, I bring down the next term, which is the 7. Remember, I brought down the negative 4x already. I'm now up to the 7. And I start again by dividing. 2 into 2 cancels out. X into X cancels out. Everything cancels out. But remember, we're dividing. So when everything cancels out, we have to put a 1. We put a 1 on top. And then we multiply everything by that 1. 1 times 2x is 2x. 1 times negative 2 is negative 2. And again, I change my signs. This becomes negative. This becomes positive. The 2x minus 2x cancels out. And I get 7 plus 2, which gives me positive 9. So my answer turns out to be 3x squared plus 3x minus 1 plus my remainder, which is 9, over the divisor 2x minus 2. But again, if you notice, the steps were divide, multiply by what's on top, by what you just put on top. The new things, each time you're multiplying by what you put on top, then you subtract, and then you bring down and start all over again. Okay? Are you ready? I'm gonna leave this one on the board.
So
Hello?
if we get 3x squared plus 3x minus 1, we could do say remainder 9, or we have to write 9.
If it's in an open, so you have to understand, it depends on how the question is worded. If it's an open-ended question, you could do it either way. Usually on a final, which is your next major test, it's going to be multiple choice. And usually on the multiple choice, they give the answers this way, though sometimes they do ask you, I've seen questions where they'll say, what is the remainder? They won't even ask you the whole question. They'll just say, find the remainder, because if you get the right remainder, then you know you've done it right. So you have to read the question. But if it's, if it's just an open-ended question, you could do it either way. Do you want me to erase this, or should I leave this one on and erase that one?
Leave that one on and erase the other one.
Okay. So let's try one more. Let me see if I can find one from a previous final. So you'll have an idea of actually the type of question you might see on a final. Okay. I'm going to put on this question that came off, actually this final was from spring 2019, so 2 years ago, when we were still doing in-class things. And I'm going to give you the problem, and I'm going to give you the possible answers. Find the quotient and remainder when the first polynomial, which is x squared plus 12x plus 25, is divided by x plus 9. Okay, they want you to divide this polynomial, which is a trinomial, by this binomial. Here are the possible answers. And I'll show you how they gave the answer. Answer A, x plus 3, comma, -2 over x plus 9. In other words, when they wrote the answer, they wrote the quotient, and the remainder they wrote by putting it over the divisor. So that was choice A. Choice B was x plus 3 and 1 over x plus 9. Here's the answer. Here's your remainder. Choice C was x plus 4, comma 0. And choice D is x plus 3 with remainder 2 over x plus 9. And if you notice, the answers are really quite similar. So let's see, I'm going to give you some time to see if you can divide this by that and see which of those 4 answers you come up with.
said turned off, right? Okay, now turned up. Yeah, we can close it, right?
Okay, I see a couple of people are already have finished. Anybody want more time?
Just like 1 more minute.
Okay. Okay, I think we can get started. Okay, since this is a trinomial being divided by a binomial, I have to set it up like a long division. I put the x plus 9 on the outside, and on the inside, I'm putting the x squared plus 12x plus 25. I know I have to do it this way because it's a polynomial divided by a polynomial. This happens to be 3 terms, this happens to be 2 terms. Remembering that everything has to be arranged in descending order, which it is. This is x squared, x number, and nothing is missing, so I'm okay. I now take my first term and divide it into the first term. X, which is 1x into 1x squared, gives me just plain x. X times x is x squared. I'm going to take that x and multiply by both terms. By the x times x is x squared, and x times 9, which is 9x. Okay, I divided, multiplied, I now am up to subtraction, and I want to do my subtraction by changing the signs. This is going to become a negative, and this was originally a positive, so it's going to become a negative. So now I have x squared minus x squared, which cancels, and I have 12x minus 9x, which is 3x, and I bring down the next term, which is the 25. And I again do the division. I start from the beginning. I divide the 1x into the 3x. So the 1 into the 3 gives me 3, and the x's cancels out. So I just get a plain 3 on top. Don't forget, the x's cancel out. It doesn't give you 3x, it gives you 3. And I multiply by that 3, because I just put that on top. 3 times x is 3x. 3 times 9 is 27. And I change the signs because I'm going to subtract. So this is going to become a negative, and this is also going to become a negative because they were both positives. So I'm left with 3x minus 3x. If you notice, every time we do that subtraction, the first term drops out and you're just left with the next. So you're only left with one term. 25 minus 27 is negative 2. And there's nothing left to bring down. So this is my remainder. So my answer is x plus 9. That's my, we'll call my quotient. And my remainder is negative 2 over, I'm sorry, My answer is x plus 3. The answer is not the divisor, but it's what's on top. And the remainder is the negative 2 over the x plus 9, which was choice A, which a lot of people did pick. So that is, and this was, as I said, I picked this right off of a final exam. As I said, I've seen it on every single final exam. So now we have finished chapter 5. I'm going to be preparing a test on Delta Math for you on chapter 5. It will be available probably starting tomorrow until next Friday. Again, it'll be of the type where you'll be given 45 or 50 minutes to complete it. I will give you a week to complete it. Okay, let me see, Jennifer, what is your, how many questions is the final? Okay, that's a good question. If the pattern continues, there will be 30 questions on the final. The final usually consists of 30 questions, 30 multiple choice questions, and it's worth 35% of your total grade. That's why even though I sent you out grades on, it's really hard to judge exactly because there's so much of the grade. We only had, I would say, including the extra tests and homework and the final, we'll probably still have close to 50% of the grade not accounted for. That mark that I sent you is what you're at right now. If it's not high enough, you have plenty of time to get that grade up. If it's nice and high, which a lot of them are, don't slack off now, because if you slack off now, that nice number in the 90s can fall into the 60s and 70s very easily. So it's just, as I said, those marks that I sent out were for you to have an idea of your standing right now. Okay, but be looking out for a test. I'll of course send you an email saying when it's available, but I would say I'm planning to have it available for the weekend, and
Professor,
but you'll have time until next Friday to do it. Yes.
so if we keep maintaining to maintain what the grade that you gave us, we just have to keep doing our homework and taking the test. And
Right.
if we don't do that great on the final, because you never know,
You never know.
we can still have a chance to pass.
You certainly can. You see, that's what they changed dramatically here. In before COVID, I guess this changed with COVID. I don't know why COVID changed it, but it certainly did change with COVID. It used to be you could get 100 on every single test and midterm and everything. And if you failed the final, you failed the course. Now, most of us felt that that was unfair because you could fail a test simply because you're not feeling well that day, or you just panic, or somehow things went wrong. But if you were doing well in the class, there's no reason for you to fail the course. So the final exam is worth 35% of your mark. Now that's a major percentage of your mark, but it's not, but if you've if you're, let's say your mark up to this point is in the 90s, and you need a 70 average to pass, you can get that even if you got a 0 on your final, which is unlikely. If you've been doing well, you're not going to. Yeah, that's why I want you to feel confident enough that you're doing well enough that you won't get that panic. You panic when you think everything depends on it. But if you realize that not everything depends on this, you just do the best you can. Even if you got, let's say, a 50 on the final, you still could get certainly a C and maybe even a B minus in the course, even if you you really did poorly on the final. My experience, and I'm really rather experienced with this, my experience is that if you've been doing well in the course all along, you'll do fine on the final. You may do a little lower than you would normally do, but you won't really bomb it, especially if you know that you're going to pass that course anyhow. So, and I hope to have enough time so that we'll have plenty of time, just like we reviewed for the midterm, that we'll have time to review for the final. The thing is that a lot of the hard work is coming up. So we have to really work on it. So I want to, this is the end, as I said, this is the end of chapter 5. I'm going to be starting with chapter 6 now. And chapter 6 is called, radicals and rational exponents. What we're going to be doing in chapter 6 is talking a lot about radicals, square roots. If you notice, when we use that quadratic formula, part of that formula had that, what we call the radical sign, the square root sign. Now, all the examples that we've been doing using that quadratic formula came out to be nice, what we call rational numbers. In other words, if I got the square root of 25, I know it was just 5. If I got the square root of 100, I knew the answer was 10. If I got the square root of 144, I know it was 12. All the numbers that ended up in the radical sign that we were working with in the quadratic formula always came out to be what we call a rational number or a whole number. But what if the number had come out to be something like 17 and I got the square root of 17? How do we deal with numbers that are what we call irrational numbers? Numbers in radicals, and specifically in square roots, because we're really going to concentrate on square roots. How do we work with them? How do we add, subtract, multiply? If you notice, each step of this course is going one step higher, one step further, one step in the, so that you're able to work with more examples. So what we're going to be going on to is working with square roots. That's where I'm going to start today. We're also going to be working with something that are called rational exponents. The exponents, the numbers that are in the powers that we've been using so far, we learned 2 types. We learned what to do when we had a whole number, and we also learned what to do when the exponent was negative. Remember, when we had a negative exponent, it means something is going into the denominator. It's taking the reciprocal. We'll review these exponent rules, but we're also going to extend our knowledge of exponents to what happens when we have a fraction and an exponent. So first I'm going to talk about working with the square roots. And then after we've done a lot of work with square roots, I'm going to talk about what happens when we have exponents that have fractions in them. We're going to see that there is a connection between square roots or radicals and between exponents that have fractions. So that's what we're going on to in chapter 6. Okay. So let's just do a quick reminder of some of the things that we know about square roots. First of all, this symbol that looks like almost like a division sign, except it starts with a check mark, is what's called the radical sign. And when I write something like radical 25, you can either read it radical 25 or the square root of 25. And what it means is that we're looking for a number that multiplied by itself will give us 25. Now, I think everybody would realize that that number is 5. Now, actually, if you think about it, there could be another answer to that, because not only does 5 times 5 give you 25, -5 times -5 gives you 25. But when we use this radical sign, we always want what's called the primary radical square root, or the principal square root, which is the positive one. So in order to avoid confusion, we don't want one symbol to mean two different things. We always use the square root sign to mean the positive square root. If I want to get to negative, I'd have to write this, negative square root of 25, in order to get to the -5. Now, this radical sign is not used just for square roots. It's used for any kind of root. For example, you might see this symbol, a number where there's a little number inside that check mark. Now that number is called the index. This is read the third root of 8, or cube root of 8. And it means what number times itself 3 times will give you 8. And I think everybody would realize that that number has to be 2, because 2 times 2 times 2 gives you 8. Notice when there's no number inside that check mark, it's as if there's a invisible 2. There is an index here, but we just don't put it in. When there's no index, it means the index is 2. It means that it's a square root. If I wrote something like this, this would be read the 5th root of -32. And what that's asking me for is a number that multiplied by itself 5 times will give me -32. Notice, if you think about it, it would be -2, because -2 times -2 is +4. +4 times -2 is -8. -8 times -2 is +16, and 16 times -2 gives you -32. The answer here would be -2. Obviously, if they're asking you questions about third roots or fourth roots or fifth roots, obviously the numbers have to be easy. From now on, not only will you be allowed to use a calculator, you're going to have to use a calculator, because we're not going to be doing too much with third or fourth or fifth roots, but we are going to be doing a lot with square roots. And on your calculator, right on your front screen, you should see a square root button. If you can't find the square root button on your calculator, then send me a picture of your calculator in the email, and I'll tell you where to locate the square root. But usually, I know on my calculator, it happens to be, I have a button. This is sort of comment on the button that says x squared, right above it, you see the square root sign, which means that you have to push the second button or the inverse button and then the x squared, because it's above the x squared. You're going to be wanting to use that button a lot, especially if you don't know all the square roots by heart. You really should know up to 12 the numbers. Like if I tell you 81, you should know 81, the square root of 81 is 9. Those type of numbers you should know. What we will see when it comes to square roots that even though you can do, let's say, the square root of 81 and we get 9, you cannot do the square root in rational numbers of negative 81. The number in, notice when the index was 5 or 3, you could have a negative number inside your square root. But when you have just a plain square root, you can't have a negative there because your answer can't be 9, because 9 times 9 will give you positive 81. And your answer cannot be negative 9, because negative 9 times negative 9 would also be positive 81. So this is not allowed in real numbers. The regular number system that we used is called the real number system. And in that real number system, it is impossible to do the square root of a negative number. Towards the end of this chapter, we're going to talk about a special kind of set of numbers called the complex number system. And in that system of numbers, we will be able to find the square roots of negative numbers, but that's for the end of the chapter. We're not up to there yet. So as of now, you cannot, and if you try it on your calculator, you usually will get an error message. It will say error or domain error. It'll tell you you're not allowed to do that. Okay. So what do we do with square roots? So let's think back to what we did in just one chapter before this. In the chapter before, we talked about fractions. So we discussed what is a fraction or a rational expression. And then after we discussed what it was, which is what we just did now, we discussed what are radicals, then we started working with them. In other words, we learned how to simplify them. We learned how to add and subtract them. We learned how to multiply and divide them. That's exactly what we're going to do here. We're going to take these radicals and learn all the operations involved in working with square roots. Again, every so often I'll say something that will be a cube root or a fourth root, a higher root, but basically we're going to concentrate on just the plain square roots, those where the index is 2. Now, first things, how do we simplify a square root? So if the number is what we call a perfect square, and a perfect square means a number that is multiplied by itself. then it's very easy to simplify. You just, and on your calculator, you could do that. You could do the square root of 144, though I think most people would know the answer is 12. And if I gave you the square root of 4, I think everybody would be able to tell me that the answer is 2. These are rational numbers. They are because they're giving us answers without any radicals. But what if I gave you something like this and I said, I want to know the square root of 8. Now, if I take out I know that 8 isn't a perfect square because 2 times 2 is 4 and 3 times 3 is 9, and I skipped right over 8. 8 is not a perfect square. Now, there are 2 things I could do with something like the square root of 8. One thing is to go to my calculator and do on my calculator the square root of 8. Now, if I do it on my calculator, I get something that looks like this. 2.828,427,125. It stops right there because I don't have more room in my calculator for more digits, but actually it keeps going on and on and on. It's what's called a non-ending, non-repeating decimal. If you notice, there's no pattern here. It just keeps going on and on and on. The only reason it doesn't go on in my calculator because I just have, it's filled up the whole 10. My calculator has room for 10 digits and it filled up all 10 digits. This is what's called an irrational number. It's not the square root of a perfect square. The number inside the radical is not a perfect square. And when you try to put it into your actual figure out what the number is equal to, it gives you this long, complicated decimal. Now, that doesn't really help us very much because even if I can round it, but it's never going to be an exact number. So another thing that we do when we have an irrational number is instead of going to our calculators, we do something that's called simplifying the radical. So that's the first thing we want to learn how to do. How do we simplify a radical? And here's what we do. We look at our number inside a radical. If it's a perfect square, then there's no problem. Just change it to its equivalent. If it's not a perfect square, break the number up into 2 parts. Factor the number, break it up into 2 different numbers that multiply to 8, where one of the numbers is a perfect square. Well, I know that 8 is actually equal to 4 and 2. If I multiply 4 times 2, that will give me 8. And not only that, the 4 is a perfect square. Notice when I rewrote this as its factors, I put the first number I put was the perfect square number. The second number I put was whatever was left over, because now I can change the square root of 4. No, is just plain 2. And the answer to this becomes 2 times radical 2. This is read just 2 radical 2 or 2 square root of 2, but it means the 2 on the outside is the coefficient. It's 2 times radical 2. If I have something like the square root of 300, now 300, if you put it into, it's not a perfect square, but 300 can be broken down into 100 and 3. Notice I put the 100 first because that's the perfect square. The square root of 100 is 10. So this becomes 10 times radical 3, or 10 radical 3. So simplifying a radical means taking the number and breaking it up into two numbers that multiply to it so that the number inside the radical that you end up with is as small as you possibly can. You're still left with radicals, but instead of having a square 300 inside the radical, here you only have a 3. Let's say I gave you, now let me give you another one. Let's say I gave you the square root of 48. Now here's where you might have to be careful. I'm trying to find 48. I know 49 is a perfect square because that's 7 times 7, but 48 is not a perfect square. So what numbers multiply to 48 that one of them is a perfect square? And there are a couple, if you think about it, if I'm breaking up 48, it could be 4 times 12, or it could be 16 times 3. There are other combinations. It could be 6 times 8, but that's not a good combination because neither 6 nor 8 is a perfect square. The two ways of breaking up 48 into two numbers that one of them is a perfect square is either 4 times 12 or 16 times 3. Now, when I'm doing this simplification, which should I pick? I pick the one that gives me the larger perfect square. So I'm going to pick the 16 times 3. I'm going to rewrite this as the square root of 16 times the square root of 3. And the square root of 16 comes out to be 4. So the answer to the square root of 48 is 4 radical 3. 4 times the square root of 3. And if you had your calculators, and from now on, I suggest you bring your calculator to class. If you put in your calculator square root of 48, I'm going to do that on my calculator. It comes out to 6.9282. It's a bunch of other numbers. That's what I get when I put in square root of 48. If I put in 4 and then the square root of 3, it comes out to be exactly the same thing. But the simplified version of the square root of 48 is 4 radical 3. Let's go one step further. What happens if there are variables inside your radical? Let's say I have the square x to the 10th inside a radical. Actually, it's much easier to deal with the variables than it is even with the numbers. Because the rule is what you do is you take your exponent and divide it by your index. Divide the exponent on top, the index on the bottom. Notice if no index is written in, then the index is understood to be 2. So this would be 10 divided by 2, which is 5. This is x to the 5th. And of course that makes sense because when you multiply x to the 5th by itself, x to the 5th, you're going to get x to the 10th. If I gave you something like the cube root of x to the 15, then your exponent is 15. Your index in this case is 3 because there's a number inside the check mark. 15 divided by 3 is 5, so that is also x to the 5th. Now, the question is, what happens if I were to give you something like the square root of x to the 9th? Now remember, when I'm doing variables, I don't take the square root of the exponent. I divide the exponent by 2. So therefore, I should, since this is a square root, my index is 2. 9 divided by 2 is 4.5. We really don't want to be left with exponents that have decimals or fractions in them. So we want to learn, how do we simplify something that has an odd exponent? What do we do with a variable where the exponent is odd? And it's really quite easy. Any odd number, because when you divide an odd number by 2, you're not going to get you're going to get an answer with a decimal or a fraction. What you could do is take 1 away from that. If you subtract 1 from 9, you're going to get x to the 8th. Rewrite the x to the 9th as x to the 8th times x, because when we're multiplying variables, we're adding their exponents, and therefore this has an exponent of 1. 1 plus 8 is 9. So I'm going to rewrite the square root of x to the 9th as the square root of x to the 8th. That's a perfect square because its exponent is even. I can divide this exponent by 2 times the square root of x. And now simplify this by, this is a perfect square. Take the 8 divided by the index, which is 2, which is x to the 4th. And your answer will become x to the 4th times radical x. So the variables are really much easier to deal with than the numbers, okay? I have like 2 minutes. I just want to do one more. This is where we're going to be continuing next time. What if I gave you something that looks like this? Square root of 50 x cubed y 6, okay? And I want to simplify this into as simple a form as possible. So the first thing I'm going to do is I'm going to rewrite this into 2 radicals. In the first radical, I'm going to put the perfect squares. In the second radical, I'm going to be whatever is left over. In other words, if I have 50, I know 50 could be broken down into 25 and 2. 50 is not a perfect square, but 25 is. I'll put the 25 in the first radical because this is a perfect square. And what's left over, 25 into 50, the 2 goes into the second radical. Then I look at the variables. So the first variable is x to the 3rd. Now, sometimes I have to separate it, sometimes I don't. If its exponent is even, it is a perfect square, so I don't have to separate it. But if its exponent is odd, then I do have to separate it. Now this has an exponent of 3. So I have to, that's not a perfect square because 3 divided by 2 is going to give me a decimal. So I'm going to break up the x squared. I'm going to take 1 away from the x cubed. I'm going to take 1 away from it. It'll leave me an x squared. And in the second radical, I'll put the x because the x squared times the x gives me the x cubed. Then I go to the next variable, which is the y6. Now, y6 is a perfect square because 6 is divisible by 3. So I don't have to separate it. I'm going to put that all into that first radical. This first radical then is a perfect square, and I can take the square root. The square root of 25 is 5. And with the exponents, I divide them by 2. 2 divided by 2 is 1, so that's just a plain x. 6 divided by 2 is 3, so this is y to the 3rd. And what's left over in the radical is 2x. And notice this is called simplifying the radical, because what we're left with in the radical is a much, much smaller, even though the thing still looks pretty long, we have simplified the radical. So this is where we're going to continue tomorrow in simplifying radicals. Don't forget to look for, make sure you're doing any homeworks that you need to do. And we're going to, and I'm going to end the session now. I'm going to leave. Are you running a session now?
I can't because I'm on my phone.
Oh, okay. So I'll stick around. Make me the host now. I'll stick around a few minutes to answer anybody's questions, or if anybody has anything they want to ask me. Okay, can you make me the host?
I'm doing that right now.
Okay, thanks. Have a good day. Thanks a lot, Melissa.
Oh, Professor, I have a question.
Sure.
I wanted to know if I could retake the Math 2,
The one on, okay.
the
Yeah,
one on Blackboard.
the one on, the second one, okay, okay. You want to retake, wait, let me just stop the recording, because